Hey guys, this is CHEMPLIFIED, and in this video we will talk about nucleophilic substitution reaction for secondary carbon. We have already discussed the nucleophilic substitution reaction for primary and tertiary carbon. We have discussed SN1 reaction. SN1 reaction are preferably given by 3 degree carbon, and SN2 reaction which are preferably given by 1 degree carbon. Right? Now today we will discuss what happens when secondary carbon is there. What type of substitution reaction will take place, whether the secondary carbon will undergo SN1 reaction or SN2 reaction. Let's start. One second. Now, for secondary alkyl halide, the nucleophilic substitution mechanism is determined by two methods. If secondary alkyl halide is there, then whether it will go by SN1 reaction or SN2 reaction, it will depend on two factors. First one is on the nature of attacking nucleophile, that is whether the attacking nucleophile is strong or weak. Second one is nature of solvent. We will discuss these two one by one. Now the first one is, let's start with the question, how nature of nucleophile affect nucleophilic substitution reaction. In that first part, A part, a strong nucleophile will give SN2 mechanism, that is substitution nucleophile bimolecular reaction. Now what it means is, it has been explained here. In simple words, strong nucleophile means that the chemical species which is unstable, aggressive, reactive nucleophile which has large electron density on it, that is lone pair of electron or negative charge on itself, it cannot wait for the leaving group to leave before it attack on the secondary carbon. This whole statement simply means that the strong nucleophile will not wait for the leaving group to leave. It will attack before the leaving group leaves and kicks out the leaving group. Right? Let me explain it a bit more. Let's take a look at this example. Now this is our secondary carbon. Right? Now this secondary carbon is attacked by strong nucleophile CN-. Now since this is a strong nucleophile, it will attack as soon as it gets the opportunity to attack, and it will kick out the leaving group. Right? Since the bromine present here is above the plane, the CN- will attack from below the plane, and that's why in the product it is below the plane. Above there will be hydrogen. Right? So that's how the attack took place. It follows SN2 mechanism. In general, nucleophilicity increases with basicity, that is strong base are better nucleophile. Remember this statement. Strong base are better nucleophile. So better nucleophile means strong nucleophile. Strong nucleophile in case of secondary alkyl halide will attack first and kick out the leaving group and follows SN2 mechanism. Right? That is single step reaction. Now these are the examples of strong nucleophiles. These are some common nucleophiles which are strong in nature, and the examples are given below. First one is carbon ions, then thiols, then hydroxide ion, alkoxide, iodides, nitrile ion, azide ion. You can also add amines, that is NH3. This is also a strong nucleophile. Right? So these are the few examples of strong nucleophile which will give SN2 mechanism. Right? Now we will go for weak nucleophile. Now if a weak nucleophile is there, a weak nucleophile will give SN1 substitution reaction first of all. Now what does it mean? In simple words, a weak nucleophile means that a nucleophile which is not as reactive as strong nucleophile. We have already discussed strong nucleophile and its nature. Now we are discussing weak nucleophile, and weak nucleophile will not attack until the leaving group is gone. Weak nucleophile will not attack until the leaving group is gone. Why a weak nucleophile is following this pattern? Because first of all, it does not have enough negative charge to attack. Right? As soon as the leaving group leaves, as soon as this bromine ion moves away, there is a creation of positive charge. Now this positive charge gives an opportunity to this weak nucleophile to attack properly. Right? This kind of attracts the electrons present in the weak nucleophile. So this provides an opportunity for weak nucleophile to attack, and then the attack finally take place and substitution reaction will occur. And the mechanism followed is SN1 substitution mechanism. One of the example for weak nucleophile is H2O, and another example that you can take is alcohol. So these are the two examples that you can take for weak nucleophiles, right? Now let's move to the second method, that is on nature of solvent. How the mechanism depend on the nature of solvent. A part, if the solvent is polar aprotic solvent, then it will follow SN2 mechanism or E2 mechanism. E2 mechanism, we are not discussing E2 mechanism right now, so focus on SN2. So in simple terms, polar aprotic solvent follows SN2 mechanism. Now this is the list of polar aprotic solvents, that is dimethyl sulfoxide, dimethyl formamide, acetonitrile, hexamethyl phosphoramide, acetone. These are some polar aprotic solvents. Now what are polar aprotic solvent? We will discuss it in the next slide. Just understood the examples and you can note them down also, right? So first one is, if polar aprotic solvent is there, then SN2 mechanism will take place. Now the second one is, if polar protic solvent is there, then SN1 mechanism will take place. This is the list of some polar protic solvent that you can write down. First one is water, then methanol, then ethanol, ammonia, tertiary butanol, acetic acid. These are some polar protic solvent. Now the question is, what is the meaning of protic and aprotic solvent? Now solvent is something in which you dissolve your reactants or whatever it is for SN1 SN2 mechanism. Now what is the meaning of protic and aprotic? Now if you look closely in this list, all these examples which are given in this list will give H+, or have the ability to give H+, right? So since they are giving a proton, we call them protic solvent, right? Now if you look in the previous list, all these examples, they are not able to give H+. These will not give H+, right? So they are polar aprotic. These can behave as solvent, but they are not providing H+ ion, right? So that's why we call them aprotic. So polar aprotic solvent will give SN2 mechanism and polar protic solvent will give SN1 mechanism. So these are the two factors on which your SN1 or SN2 mechanism for secondary alkyl halide depend. First one is on nature of nucleophile, whether the nucleophile is strong or weak, and second is nature of solvent, that is protic and aprotic, right? So these are the two factors that we have discussed today. I hope you understood and I hope you remember this concept for secondary alkyl halide. Thank you very much for watching.